Iquique, a coastal city in northern Chile with a population of just over 180,000, is a seismically active region near the South American and Nazca tectonic plate boundary. On the 1st of April 2014 at 8:46 p.m., an 8.2 magnitude earthquake, which later triggered a tsunami of 2.11 meters, hit Iquique. An earthquake is a series of vibrations induced in the Earth's crust by the abrupt rupture and rebound of tectonic plates in which elastic strain has been slowly accumulating. With its epicenter just 95 kilometers northwest of Iquique, it had devastating effects, costing 6 lives and heavily affecting many more. A big concern during earthquakes is the stability of structures, assortments of elements that transfer load from one point to another. During earthquakes, extreme loads are applied to the structures, causing a range of effects such as permanent deformation and eventual collapse, which could prove to be fatal, as in Iquique, where a woman was crushed when a wall collapsed. Effects of an earthquake that can affect structural stability include ground shaking, surface rupture, liquefaction, landslides, and tsunamis. To prevent devastating structural damage, we must construct infrastructure on adequately load-bearing soil, with bracing and strong connections, regularity in elevation, and base isolation, whilst also adopting capacity design. Another concern is the seismic slope stability of site-supporting infrastructure. If the site is a slope comprised of granular soil composed of sediments with an insignificant proportion of fines, there may be soil transition between different elevations in a field during the ground shaking of an earthquake. This can heavily damage the structure built on these sites, as seen in Iquique's municipal stadium and A16 route. To prevent this, a structure built upon a slope must have a friction angle greater than the slope angle so that its factor of safety is greater than 1, meaning that the structure is stable. Evacuation and crowd management plans are also important in earthquakes. Due to previous experience, Iquique was able to use effective evacuation plans during the 2014 earthquake, and approximately 928,000 people were successfully evacuated. Effective evacuation orders must evacuate crowds in under 8 minutes. To do so, evacuation plans must avoid changing of levels through steps and slopes, avoid mixing people with moving vehicles, aim for a steady flow of movement without changes in direction, evacuate people to appropriately large and stable safety zones, and clearly communicate the plan to the crowd. As we've seen, the areas that were cause for concern in the Iquique earthquake were structures which lacked strong connections and had an unstable design, and granulated soil which lacked support to the vertical load created by buildings and infrastructure. However, their evacuation plans were efficient and successful in saving people's lives. Therefore, we suggest that structures are built with the aim of resisting ground shaking, where a friction angle is higher than the slope angle, allowing for stability, and evacuation plans are designed to be as efficient and safe as possible, as well as being well communicated to citizens. We must also monitor seismically active regions to provide warnings of incoming natural disasters in time. If our suggestions were put into place in all seismically active regions, we could expect to see a decrease in devastation.